بسم الله الرحمن الرحيم. السلام عليكم شباب وصبايا. As you can see in this very clear, nicely written notes that I have done for you the past 2 days, I preferred that everybody should have a copy of these notes plus my explanation in a record so that you will refer to it anytime you want. So let's start with that. The first couple of pages that I have already delivered them during the lecture, I will go through them fast, and then the new pages I will slow down. All right, because I assume that everybody attended the first couple of pages. So as we mentioned, this is a Newton's second law, F is equal ma. We went through all that, and if we are stressing on the important points, and if we say that the object stays at rest, it doesn't mean that there are no forces acting on that object, but it means that the net force acting on that object is equal to 0, which will make the object at rest, because definitely m will not be equal to 0. So if net is equal to 0, it means that the acceleration is 0, which means the object will not move. Now, if the net force, and again we are stressing on the word net, it means that there could be a couple of forces acting on the object, but their resultant, you remember from the chapter where we explained vectors, we used a lot the word resultant, or we use the word net. So the net force, if it doesn't equal to 0, then the object will move definitely with acceleration of a. Great. So now, and we come across the free body diagram. You will hear the word free body diagram a lot, and you will be asked many times in any question whenever you start your problem in this kind of like, you know, an object is on a surface, either it is horizontal or it's inclined plane, they will start first asking you draw the free body diagram for your problem and then start solving. A free body diagram, we want to show the forces acting on the object. That will help us a lot. So if we have simply an object of mass m and it is there on a horizontal surface, this is called simple horizontal surface. Definitely, we all know that there will be no motion. We will say also that the object is at rest, or we will say the acceleration is 0, or the F net is equal to 0. These are the 4 alternates to express what is going on with this object. It's at rest. It means no motion. It means acceleration is 0, which is all caused by having F net is equal to 0. Great. But does that mean that there are no forces acting on the object? No, that is not the situation. There are a couple of forces acting on that object. The first force that we all know is the force of gravity, which is F sub g. And I will keep saying sub g or F sub n or F sub net, because you should know that these are not two letters near to each other like m and g here. You see m and g, they are written near to each other. But this is a sub letter. So it's F sub g, the gravitational force. Notation is important here because we have the vector sign, we have the sub-note sign, and we have the normal variables multiplied by each other. So I hope that you will take that notation serious. Now, we mentioned that the force of gravity is always down, There is no exception at all for this kind of whatever rule or direction. If g is always down. Is the force of gravity the only force which is acting on the object? No, because if only the force of gravity is acting on the object, then maybe our object will break the surface. It will go down because we clearly can see that there is force downward, but why the object is still at rest? It means there is another force acting on it, exactly equal to Fg and opposite in direction, which make the net force overall equal to 0. That force is called the normal force. The word normal, in mathematics point of view, the word normal, I hope guys that you are somehow taking some notes at least. So for yourself, you will at least, because no matter what I do, no way I will write down everything, I try my best, but still. The word normal, it means perpendicular. The word normal, in mathematics point of view, the normal to the surface is the perpendicular to the surface, which is with an angle of 90. Now, from the name normal force, this force is always perpendicular to what? To the surface. So, there is a force acting from the surface on the object perpendicular to the surface, and that force is called F sub n. Or in easy way, you can say n vector or n lowercase vector. We can use any of them and it is correct. Just when you are in the same problem, make sure that you are stick with one note for normal force. So we know that you are referring to normal force. This force is always perpendicular to the surface. And to show this more clear, I brought for you an inclined plane. What is the meaning of inclined plane? The plane, which is not simply horizontal, it is a plane with an angle of theta with the horizontal. It's a plane with an angle of theta with the horizontal. All right. We can see that even though the plane becomes inclined, but yet this is our object M, and the gravitational force F sub g is downward. It's downward. And the normal force is literally perpendicular to the surface. You see, they are not exactly opposite to each other. While here, if we draw both of them on the same graph, you will see that one is up, one is down. They are on the same y-axis, but one is up, one is down. But here, since our plane has been inclined with an angle theta, they're not on the same line anymore. This is perpendicular to the surface, this is downward. So they will not cancel each other. So from here, I hope you understand that they are not a pair of action and reaction. This will come again. I am repeating that. I mentioned it, but I am repeating that now, that normal force and the gravitational force, they are not according to Newton's third law of action and reaction, because many people, they mix this point up. They always say the normal force is exactly equal to the gravitational force and opposite in direction because of Newton's second law, action and reaction. But immediately when we saw the inclined planes example, we realized that they are not necessarily to be equal to each other, opposite to each other. So they are not a pair of action and reaction. And another thing, that in Newton's third law of action and reaction, the force of action will be on one object, the force of reaction will be on the other object. And I recall here the example of hammer and nail. There is a force from hammer on the nail, and there is a reaction force from the nail on the hammer. So if you see, again, I am repeating, force from hammer on the nail and force from the nail on the hammer. Both forces are acting on different objects. The first one is on the nail. The second one is on the hammer. That is a pair of action and reaction. They are on different objects, but they are equal to each other and opposite to each other. That is called the law of action and reaction. I hope that you go through these examples in the book and you can understand the action and reaction in a better way. But here, the gravitational force is acting on the object M. And the normal force is from the surface also on the object M. So both F sub G and F sub N are acting on the same object. And since they are acting on the same object, Newton's third law does not apply. Now you can go to the opening question in this chapter and, in the first page of the chapter, and you can answer it, since we address Newton's third law that it should be on different objects. And then we have action, reaction equal. The forces are equal in magnitude, opposite in signs, and they cancel each other. But this is definitely not the situation here, because we can see the moment the plane is inclined, that is cancelled. Means that is cancelled, I mean that N does not equal to Fg anymore. All right. Now, we come to little bit more details, and I will go through this picture first. I wrote a lot of explanations mathematically and from Newton's second law point of view, but I will just go through this picture now. Again, we have the object M, and there is force of gravity acting on this object, and it is F sub G. And there is also a force acting on object M. Again, I keep repeating, on the same object, but this time it's not due to gravity. It's from the surface where M is lying or is sitting. So as now I can say, as a reaction of M sitting on the surface is basically applying a force on this object upward, perpendicular to the surface. All right, but we all know one thing. We all know that in this situation, the object is not moving, the object is at rest. And I am saying again that acceleration is equal to 0. I want here to add a little bit more details. Here I say acceleration along the y-axis. Why? Because definitely the forces, if you see where I am pointing the cursor, the forces are along the y-axis. So if there will be any motion which there is none, then it will be on the y-axis, because the force is on the y-axis. That's why I wrote A sub y is equal to 0. But really, since the object is not moving, so it does not really matter to say A sub y or acceleration in general. All right, guys, I have to meet you now. So I will stop recording here, and I will get back to this in a few minutes.